Hi, I'm Paco from O'Reilly Media. We're at JupyterCon, and I'm here with Aaron and Pramit from datascience.com.
That's right.
And I'm super glad to be talking with you all. This is kind of a roundtable, ad hoc roundtable here but us three have been presenting about human in the loop and talking about model interpretation. It's very much emerged as a theme of the conference. A lot of the keynote speakers we've been talking with have been underscoring the need, the priorities for establishing trust. And I've seen this over and over in the keynotes. And I think that what you all have been working on at datascience.com in terms of Project Skater really begins to address this here. So can you dig into this a little bit for us and tell us a little bit about Skater?
Sure. First of all, thanks for inviting us here. We are very excited. First thing, when we decided to work on the Project Skater, it was coming out of a need. And we're building a lot of models for different clients, and there was often a need to articulate that when we say it's giving 90% accuracy, or the client would come and say that, we had 90% accuracy, can you help us improve? So then there was this need of understanding the domain better. And in a real life use cases as well, understanding the features well is the single most important thing.
Right.
And tracking its lineage as to how it is changing. Back in the days, we used to have expert and non-expert systems. Expert systems would be you change, you would have this UI where you could alter the feature space and you could see the predictions changing. Long back, especially in the oil and gas industries, you'll have this old UI systems, right?
Yeah.
Because there it's very critical. As modeling has evolved, I feel, and started applying its use case to real-world problems. Finance has been doing it for some time. But they have a lot of times, I feel that a lot of people have been sticking to linear models. It's very recently, with the access to computational resources, deep learning models are coming back into the phase again with real, proven application, result-oriented applications.
So some of the regulated industries, particularly finance, even if you had a better solution with a more complex model, they would still revert back to a very simplified linear model for the explainability.
Yes.
And pros and cons of that, but definitely it's not the best that we could do.
Right.
Yeah, and I would just say, from our team, with a diversity of analysts working on different problems, using different languages, using different learning algorithms, we really found the need of creating, we're not complete there yet, but starting to work toward a unified language of how do you explain a model, regardless of the implementation, the algorithm, the language. And this is really a rich idea, because you can compare, apples to apples, a random forest to a neural network to a regression with the same set of visualization tools. So we think it's a really rich direction, and we've only started to scratch the surface, I think.
Now, that would be also breaking the silos. I mean, there's the people working in R, and the people working in Python, the people working in Go, or whatever else isn't invented today yet.
Right.
Yeah. Yeah, it was important to us, too, as part of the early releases of the package, to support deployed models as well, such that avoiding the sort of PML sort of framework for now. If you need to,
chicken and egg,
yeah. So if you need to deploy something in a different language, at least we gave some tools for that. So you could deploy it as a web service, and then Skater would interact with it, the same way it would a native Python model. But we're really excited to kind of grow the degree to which it can interact with models in different places and different languages as well.
Wonderful. Are there? Well, so it is. I guess there's a similar sense of serializing out metadata. There's some things akin with where PML had gone, but I mean that standard's going back into the 90s or so. Yeah. Excellent. Where have you seen in industry where this is gaining some validation, where this is gaining support and momentum from business?
So I feel that I see a lot of good blogs and papers and insights coming out of finance, healthcare specifically.
Yeah.
And then again, as you mentioned, criminal justice systems, anything which has a very direct impact. I feel that that's where I've seen a lot of validation. Now recently with the adoption of deep learnings for image classification, visual Q&A, people are like, I just don't want to know that your model gave me a class A as the prediction.
Right.
Can you also tell me why it did that? So actually, let me take a step back. So that is with respect to regulatory and healthcare industries, or finance and healthcare industries. I feel that, from my experience, I see its penetration in a lot of other industry applications as well, or across industry, I would say. From my experience, more often I've seen that there is a disconnect between the engineering and the data scientist.
Right.
So they would build a model with 90% accuracy, and there is a big battle which will go on to push that model into production. Right. Maybe it's a trust. It goes back to the same trust thing, right? Trust and transparency. Boss is like, I don't know if it's gonna do well because I'm not able to understand, because maybe over years he has developed some insights, right? He wants to understand, she wants to understand can I see those variables being captured in the same aspect? Then I have trust that this model might go out and do well.
And I can imagine also, typically the software engineers are really not trained to work with uncertainty. Software engineers are thinking of logic,
right?
And when you present them with systems that depend on uncertainty, now, we're having to retool. We're having to rethink even how we do that.
Right. I would also say that, even the business users. There was a phase when business users were like, fine, give me a 90% accurate model or 99% accurate model. I'm good with it.
Sure.
Now, so over the years, there has been a lot of failures with respect to data science initiative. Everybody wants to do it, but not everybody is able to get good value out of it. So then the business users are like, we want to understand more about the science. When you build a model, can you... I remember the saying from Einstein. He said that if one is not able to articulate a principle in physics to a kid, basically simplify whatever formulation it is, that you could explain it to a kid, then it's not a good solution.
Right.
I feel that applies to the models we build as well.
Interesting.
Or a way to articulate that way.
Oh, very good. Now, it seems that this will expand back not just as something to satisfy a regulatory requirement, but it sounds like what you're working on here speaks to software methodology in general. How do we work together as engineers? How do we collaborate across teams?
Right.
Not just I think it's excellent about the data scientists and the engineers establishing trust for shared artifacts.
Right.
But I think it's broader than that. I think it's across teams that are collaborating on open source projects. I mean, it's very scalar to think of a unit test, match one or match all.
True.
And now we have to work with more unit tests that embrace uncertainty and more. Tell me more about that. I shouldn't be talking too much.
Well, no, I suppose I see skaters kind of belong to the superset of a particular approach to understanding a black box, right? So the idea being that I have some function that does something. It could be a model in our case, or something else in software, and I want to learn more about it under a condition of uncertainty. And so I decide to strategically feed it inputs, observe what it does, and make an inference between that to learn more about its internal structure. So I think that paradigm, there might be some interesting applications there for unit testing, software development around that as well, for sure.
What kind of range of machine learning models are you working with right now? I mean, is there a scope to this, or can you really just start with a black box and work back?
Yeah, so it really will work on any algorithm that currently exists and anything that will be predicted, because it's predicated on just the assumption that you can give it an input and observe what it does, and can completely ignore any mechanics internally.
Or is there any breakdown in terms of supervised learning versus unsupervised learning?
So just building on that aspect. So right now supervised kind of gets tricky.
Okay.
Right, because we don't have an idea as to where we are headed. So I'll take clustering as an example. Skater right now is not designed for that.
Right.
but it is something that we are looking into understanding.
Good.
So I'll say, let's take PC as an example. So when we look at an image, and it's the let's say, for example, and we have the digit classification data set that is there. Can one just apply PCA and see what those principal components are that could help me cluster the digits?
Right.
So maybe that's one use case that I could think of.
Some explainability.
Right.
Yeah.
But then there it becomes tricky again. Do I use TensorFlow to do that? Do I use sklearn to do that?
Okay.
Because now scalability is an option as well, right?
Yeah.
Do I use H2O to do that, or some other framework for that matter? And that I feel that so that's another place where industry struggles with. It goes back to the testing aspect that you were mentioning.
Right.
We have so many frameworks. Even when we think of a particular unsupervised or supervised problem, the algorithms may not behave the same way even
Right.
across frameworks.
Right.
And Skater, so like initially with respect to supervised learn problems, our hope is that we solve that well before diving into the space of unsupervised.
Well, and also, I mean, the big wave right now is deep learning and all
Yeah.
the diversity of applications in deep learning.
Yeah.
And it's a hard problem to understand what deep learning models are doing. So this is so valuable to be able to get that kind of introspection.
Yeah, I mean, I think that the next big challenge on supervised models is, while technically the algorithms should work on any supervised model you put into it, for it to be useful, right, every explanation that we provide is with respect to the features that you put into it. So if there's no inherent interpretability with your feature set, for instance, if you're working with genetics data with thousands and thousands of genotypes or proteins, explanations with respect to those may not be the most useful. The cardinality or dimensionality is just too high.
Yeah.
So one thing that we're very interested in is adding in some element of representation learning in the middle, whereby taking some input, can we learn a representation of that is interpretable and express explanations in terms of that, which is one reason why we're very interested in human-in-the-loop systems, because to some degree we need to constrain the set of representations to the subset that the human can understand, which obviously needs human input for us to do successfully.
This is sort of gotcha. So, I'm struggling to paraphrase here. I don't know if this would be apt, but we talk about like dependency injection. But here, for human in the loop, it's almost like interpretability injection. So we have some humans helping to bootstrap that.
Right.
Yeah. Which there's, I think, one of the most interesting or more developed cases of that is actually with topic modeling, where for natural language, where the problem statement is give me n topics that characterize a data set, so I can get a quick glance at the types of documents I'm looking at.
Right.
The big problem with topic models is that without constraints, there's no guarantee that the topic itself makes any sense. And there's been a family of algorithms developed to add words to grow topics around a certain concept, to combine them and to allow a human to sort of supervise the unsupervised algorithm to a degree, and to kind of constrain the results to be something that's interpretable.
Because, I mean, just for some context, my experience with using LDA, for instance, for topic modeling, very sensitive to noise.
Yeah.
And so sometimes it's hard to work with what you get out of it.
Yeah.
Unless you adjust it over and over and over.
Yeah, I mean, we're making really high demands of our, unsupervised algorithms to just learn this very interpretable, latent structure where, the latent structure may or may not be something that we recognize, and providing a little bit of guidance with an interactive system, I think, makes a lot of sense for that.
Excellent. Have there been any conferences along these lines, any kind of gatherings, or what does community look like for model interpretability now?
I feel that from my knowledge, there are a couple of conferences that I feel they've been around. There's one called, I think, Fair ML or something like that.
Okay.
But it would be very interesting to see. So, like I was mentioning, Capital One took an initiative to organize a conference just on this specific thing, on model interpretation. It would be great if we have a lot more industry participation with respect to specific conferences, because then I feel that a lot more people might come up and talk about the real world challenges that that they face. For example, a lot of auditors, they came up and said that, we have to we build these models, but since we are the guys who have to make the decision with respect to auditing, there is a lot of pressure on us, and we need defense line. We want things to be explicit.
Right. You need to have that kind of depth.
Yes.
Otherwise, it's brittle.
Yes.
And these people are in the hot seat, and they're going to get sued.
Right. And we see that, right? So.
Interesting. So, and so finance is an excellent example. I'm sure manufacturing and transportation, self-driving cars or jets flying around the world. We've also talked about diversity in terms of the ProPublica thing we were talking about, looking at sentencing guidelines, parole, where judges were basically just pushing the button, and the model's completely opaque.
Right.
Right. And I think another case on fairness and is within the market for credit, right? You want to ensure that you're not discriminating based on race, and what's really challenging about that is you may not explicitly doing that, but if I know your zip code, for instance, and I condition on that as part of a model, while I'm not explicitly, discriminating based on race, there might be an overwhelming, disproportionate population of one group or another in that zip code, and so having a tool set that can understand, how do credit models work with respect to some demographic characteristic, even if the scoring is opaque. Being able to make that assessment, I think is really important. And we've seen a few companies that provide credit solutions become very interested in that.
So it sounds like then that the audit process, or really the accountability of it, is, well, number one, getting the transparency, getting the model interpretation, but then number two, using that to understand and drill down on the source data, which may have other factors that are way imbalanced. And you just won't know until you can see what they are.
Absolutely.
Actually, you touched on a very good point. So, like you said, there are two aspects. One is the end user who is receiving a prediction based on the score. You want to buy a car, what's your credit score? You sign up on eHarmony. Why did I get this match? You sign up for food app. Why did this app recommend me this particular product, this particular food item? Netflix, I don't know if you guys have noticed recently, they have started showing the percentage match on the top left corner of the UI itself as well. So that's the end user. So who are the receivers? And the people who are building this are the second aspect of those folks for whom it's kind of important, because they are the ones who have to hold the defense line.
They have the liability.
The liability.
Or
so they're like the two aspects. One I feel is the accountability, and is the justification for the end user, so that they are satisfied. Otherwise, we feel like we're walking into an age when people are just recommending us stuff, and we have no control on it.
On top of that, I've heard so many people who will create separate profiles on Netflix. Because they're trying to hack the recommendation system, because they don't always want the same thing, and they have some notion of the algorithms that are working on their viewing history, but Netflix isn't providing you an explanation as to why it's making a recommendation.
Well, thank you very much. I really appreciate it. I wish you all the best on this, and I look forward to getting involved with Skater and all too. Highly recommended.
Awesome.
Okay.
Thanks again for having us, Michael.